Natural gas is emerging as a major motor vehicle fuel. It's clean burning, cost effective, and the supply is abundant, especially in North America. And there is a new aluminum composite reinforced cylinder that is lightweight, corrosion resistant, and allows the natural gas industry to offer a truly practical alternative fuel for motor vehicles. The dramatic tests you are about to see answer questions about the safety of this fuel system and the strength of the aluminum cylinder. The U.S. Department of Transportation and the Canadian Transport Commission have stringent testing guidelines and performance criteria which new alternative fuel systems must meet. The new composite reinforced aluminum cylinder has been manufactured in full compliance with DOT and CTC regulations. And the following tests demonstrate performance over and above the requirements of DOT and CTC. CNG, manufacturer of this new cylinder, conducted these tests under the supervision of Authorized Testing Incorporated, an independent, disinterested inspection agency approved by DOT and CTC. There is a persisting misimpression that a vehicle using compressed natural gas would be hazardous in the event of a collision. The following series of tests, however, demonstrate that vehicles fitted with the new CNG fuel cylinders can withstand substantial collisions without creating serious hazards. Dropped from 30 feet, this 1966 Pontiac was moving at approximately 30 miles per hour at the point of impact. That is the maximum speed at which new car makers are required to test the integrity of conventional gasoline tanks. The CNG cylinder, pressurized to a standard 3,000 psi and mounted in the trunk of the car, withstood the rear-end crash with no meaningful damage or dislocation. Fuel lines to the engine were kinked but showed no damage. Subsequently, the same cylinder withstood pressurization to 7,500 psi, the minimum burst pressure required by federal and Canadian government authorities, showing that the tank had maintained its integral strength despite the crash. In each of these tests, the natural gas cylinders were fitted with standard CNG cylinder brackets, mounted in the usual trunk position, and pressurized to the standard 3,000 psi. At 50 feet, this Ford Maverick impacts at 39 miles per hour. The car's rear end collapses against the solid floor, substantially wrecked. But again, the CNG cylinder remained intact and undamaged. At 70 feet, this 1973 Oldsmobile has accelerated to approximately 46 miles per hour at impact. The momentum of the engine mass actually increases the severity of the crash. Yet there was no damage to the cylinder or any indication of movement. It stayed securely locked in its brackets. The valve and pressure relief device on the cylinder remained intact and functional. At 90 feet, this 1973 Mercury Marquis is traveling at approximately 52 miles an hour at the time of impact. As in most of these tests, the gas tank is clearly destroyed by the crash. The engine is torn loose from its mounts, and the frame bends. Yet, ironically, the two CNG cylinders, 10 and 13 inches in diameter, actually absorbed and distributed a portion of the energy of impact. At the same time, they survived the crash intact and were still functional. Note that even if these new CNG fuel tanks had allowed the escape of gas, there would have been no pooling of a flammable fuel near the wreckage. Unlike propane or gasoline, natural gas is lighter than air and vents off into the atmosphere. But what if a fire occurs? How would these new CNG fuel tanks perform? The answer comes in the next series of tests, required by the U.S. Department of Transportation and Canadian Transport Commission. The fuel tanks, made by the CNG Cylinder Corporation, bring an exclusive double redundant safety design to this high-temperature situation. The aluminum itself has a melting point of 1,200 degrees Fahrenheit, while the composite reinforcement that doubles the strength of the cylinder against internal bursting maintains a usable tensile strength to about the same temperature. While the heat is concentrated at the bottom of the cylinder, the high thermal conductivity of aluminum distributes the heat quickly. And although aluminum anneals at high temperatures, cylinders subjected to these bonfire tests withstood hydrostatic burst tests above the minimum burst pressure of 7,500 psi. The pressure relief device vents at this point. Amazingly, the natural gas does not ignite, even though a rubber gasket on the bracket mount does catch fire. The ignition temperature of natural gas is 600 degrees higher than that of gasoline. How would these